All right, look at the chart below. Fill in the value in standard form. So standard form is just the normal way to write a number. So this number here is saying 10 times 10, which is 100, times 10 again, which is 1,000. And the shortcut of doing this, you get to recognize a pattern, is that you're going to write down as many zeros as there are exponents here. So there's an exponent of 3, so we'd write 1,000. This will be 100, and then 10 to the first is just plain old 10. Now 10 to the 0, people always get messed up, but if you notice the pattern here, you're dividing by 10 each time. So you want to keep dividing by 10. So if you keep dividing by 10, 10 divided by 10 is actually 1. A lot of people, they'll put 0 here, but that's incorrect. 10 to the negative 1, we're going to keep dividing by 10. So if you divide 1 by 10, it looks like this. It's just simply a fraction, 1 over 10. This one will be 1 over 100. And then the last one will be 1 over 1,000. The other pattern to notice here, because they're talking in 14 about what negative exponents do, of course they make fractions, so you can just write that there. But the 10 to the negative third, if you look at that one, 10 to the negative third is 1 over 1,000. 10 to the positive third is 1,000. So their relationship is that they're actually reciprocals of one another. The negative and the positive exponents. 1 over 100 is a reciprocal of 100, so it's pretty cool stuff. 15, 4b to the 7th over 40b to the 5th. This is a popular one to get wrong. So let's go with this right here. If I have 4/10, I think most people understand that this simplifies to 2/5. But the reason that that simplifies to 2/5 is they have a common factor. 4 is the same as 2 times 2, and 10 is the same as 2 times 5. If you have the same number on the top and the bottom in a fraction, they cancel out. 2 divided by 2 is 1. So that's where I'm left with the 2/5 here. So if I have the same number on the top and the bottom, 4 and 40, 40 is the same as 4 times 10. These things will cancel out. So you're really left with 1 up top here. So you have 1, and then you have b to the 7th, which really means b times b times b over 10, and then there's 5 more b's on the bottom. So again, the same principle of these 2's canceling out is going to cancel out these b's here. So if I cancel out 1b, these b's, hopefully all the bee population doesn't really go. There's an issue with bee populations and honey and stuff. All right, b times b's on the top and 10's on the bottom. So you get b squared over 10. That's your final answer, actually. And you could put 1b, but the 1 won't, that's coefficient doesn't have any value. If you multiply something by 1, it doesn't change. So b squared over 10 would be a final answer. The diameter of the moon is about 3 5/10 times 10 to the third. The diameter of the Earth is 3.7 times larger than the diameter of the moon. I'm laughing because I'm thinking about this word diameter here. You don't even need that to solve the problem, but it's throwing everybody off. Write the diameter of the Earth in scientific notation. So here's the moon. Just so you know, the diameter just means that it's the distance from the one edge of the circle to the other passing through the center. The Earth is much bigger than the moon, so we'll make it a little bigger here. There's your Earth. And that's going to be 3.7 times larger. So this number here, 10 to the third, means 1,000. And if you do 1,000 times 3, it's 3,000. So if you do 1,000 times 3.5, it'll be 3,500. That's how big the moon is. 3,500 kilometers. So I'm going to write the moon next to that. The Earth is 3 7/10 times bigger than the moon. So I got to take this number right here, and I'm going to multiply it because it says times larger by 3 7/10. So that's your first row of numbers there, and then your second row. So there it is. That's the Earth right there. It's 12,950 kilometers in terms of diameter. And this number does make sense if you think about 3,500 times 4. That would be about 14,000. So this will be a little bit less than 14,000. The other way to do this, I'm just going to show you a different way, is just to multiply 3 7/10 by 3 5/10. And the reason I'm doing this is that the 10 to the third, I can just add those 3 zeros after the fact. And you can see here, I got the same answer. There's 5, there's 9, There's 2, there's 1. The other thing that this method does is it helps me answer the actual question, which said to write the diameter in scientific notation. So this is not scientific notation up here in green, that's standard notation. So in scientific notation, I would write 1 in 295 thousandths. Notice I went from 12.95 to this number because if you recall, scientific notation has to be less than 10. So I'd multiply that by 10 to the 4th power because it was 10 to the 3rd power up here, but since I moved the decimal over one more spot, means I'm dividing by 10. That means I need to multiply this by another 10. So there's my final answer, 1.25 times 10 to the 4th power.